Hello everyone, welcome to the video of chapter number 1 solid state. In this video we are going to study non-stochiometric defect. In the last video we have studied Frankel defect and Schottky defect and impurity defect. In this video we will be studying non-stochiometric defects. So let's proceed. Now, non-stochiometric defects. What are these non-stochiometric defects? The defect arising when the ratio of number of cations and number of anions are different. As we have seen in the stoichiometric defect, the number of cation and the number of anion remains same. So it is called as stoichiometric defect. Since in this defect, the number of cation and the number of anion is changing, so these are called as non-stochiometric defect. So in this defect, stoichiometry of the compound is changed. Now when the change in the stoichiometry is there, it causes the change in the crystal structure also. In this defect, the cations and anions ratio is disturbed either because of adding or removing the ions. This defect arises either due to the excess of the metal or non-metal atom or presence of impurities, that is a foreign particle. Now there are two types of non-stochiometric defect. Now let us see which are these two types of non-stochiometric defects. Metal deficiency defect. In this, solid have less number of metals relative to the described stoichiometric proportion. Second, we have metal excess defect. There are two types of metal excess defect. Metal excess defect due to the presence of extra cation at interstitial site. In this, on heating, the compound releases extra cation. These cations occupy the interstitial site in the crystals and the same number of electrons goes to the neighboring interstitial sites. Then we have another in the metal excess defect. We have metal excess defect due to anionic vacancies. This occurs due to the absence of anion from its original lattice site in the crystal. Therefore, instead of anions, electrons occupy their position. Now, let us see this in detail. Before that, let's summarize with the flow chart. As we know that non-stochiometric defect is divided into further two types, metal deficiency defect and metal excess defect. Metal excess defect is divided into further two types by a neutral atom or an extra cation in the interstitial. Whenever there is an excess of metal which is a neutral atom or extra cation in the interstitial position, or by a anion vacancy which is also called as F centers. Now let us study in detail metal deficiency defect. Such defect found only in compounds of metals that show variable oxidation states. In certain cases, one of the positive ions is missing from its lattice site and extra negative charge is balanced by the presence of the cation of the same metal with a higher oxidation state than the missing cation. Let us understand this with the diagram. As you can see in this, a cation is missing. Now when a cation is missing, it is replaced by a cation which is having higher oxidation state. Oxidation state of A is A plus, whereas it is replaced by A2 plus. So when A2 plus is replaced, it will replace 2A plus ion, and A2 plus will occupy one vacancy, one A plus, whereas other will remain vacant. This is observed in FeO, Fes and Ni. Now let us understand this with the help of an example. For example, in NiO, one Ni2 plus ion is missing from its lattice point. To compensate for the deficiency of two positive charges is made up by the presence of two Ni3 plus at the other Ni2 plus site. Now as we could see in this diagram, there are two Ni plus ions are replaced, but it is replaced by Ni3 plus. So two sites are occupied. So if it is Ni2 plus, so 3 Ni will be replaced, but one vacancy is there, and this is a metal deficiency defect. Similarly, we have this defect in FeO also. For compensating the missing of Fe2 plus ion, two Fe plus 3 ions are present at the other lattice sites. As we can see in this diagram, there is a defect developed over here. Now let us see metal excess defect. There are two types of metal excess defect, that is a bi-neutral atom or a extra cation at interstitial position. For example, zinc oxide shows two ways for the metal excess defect. Zinc oxide lattice, a neutral atom, zinc atom is present in the interstitial site. As you could see in the diagram, the zinc atom goes into the interstitial space. Now how exactly this zinc atom goes into the interstitial space? Now if we see the reaction for the zinc oxide, that is a decomposition, zinc oxide on heating will give Zn plus 2 plus half O2 plus 2 electron. Now this Zn plus 2 which is there, it is trapped in the interstitial site, and when Zn plus 2 is remaining and 2 electrons are remaining. So these 2 electrons also occupy the interstitial sites. Hence, if we see the diagram, Zn plus 2 occupies the interstitial site and even 2 electrons occupy the interstitial sites. So this is defect arise due to the anionic defect. So in both the cases, non-stochiometric formula, that is zinc oxide, is Zn1 plus X O 1.0. Now let us see anion vacancy defect, that is color or F centers. It is also called as F centers. This type of defect imparts color to the colorless crystal. Now how exactly this defect imparts the color? Let us see. For example, sodium chloride, when we are heating, it possesses the vapors of the sodium. Now this vapors of the sodium decomposes on the surfaces, and Cl minus diffuse to the surface of the crystal and combine with the sodium atom to give NaCl. The released of electron diffuse into the crystal and occupy the anionic sites. These anionic sites occupied by the unpaired electrons are called F centers or centers. For example, in this Na is being, when we heat it, it decomposes into Na plus and Cl minus plus electron. As Na plus, when it loses electron, it becomes Na plus. So Na plus and Cl minus will combine, but the electron which is there, it will occupy the interstitial space. So the electron first absorbs the white light and then it reflects the yellow light. And so we are getting yellow color for the NaCl when we are heating it. So this is what it is, a F centers, that is the color is developed to a colorless solids. Now as we can see in this also, the electron occupies the space and hence it is an F center in the crystal. NaCl imparts yellow color due to the formation of F center. Crystal of NaCl has excess of Na. So the non-stochiometric formula of NaCl is Na 1 plus X Cl 1. So thank you for listening patiently. We will be continuing with the defects in the further lecture.